Hi and a very good day. So for this video session, I will explain to you one of the topic under univariate modeling technique, which is exponential smoothing technique. Okay, so before we begin, under univariate models, we say that we group the model into three common group, which are first naive models. Okay, we have naive forecast, naive with trend forecast. Okay, methods of averages. Okay, average forecast, average change model, and also average percentage model. Okay, so for this video, I will specifically discuss about exponential smoothing technique. Right. So okay, let's take a look at what are the meaning of exponential smoothing technique. Okay. Okay. Uh, we already discussed methods of averages and naive model in our class. Okay, but of course, I will try to produce some videos for your revision. Okay, so here, what are exponential smoothing? Okay, right. Okay, for general introduction, okay, again, when we're talking about univariate, it means that you need one variables. Okay, you need only one variables, and then with that one particular variables, we will model, and then we will predict, we will forecast the projection of the future value based on the historical data, right? So again, under exponential smoothing technique, okay, the general discussion is it is actually the most widely used of univariate time series model. Okay, because of what? It is actually quite an easy to understand and to apply, especially it just need a spreadsheet program to run the model, such as Microsoft Excel and so on. All right, and this is actually quite easy to do. Okay, I will show the demo after this, but of course, right, every model they have their disadvantage. Okay, so for exponential smoothing technique, okay, you have to understand that it will depends on how we define the smoothing parameter, or how we weight the smoothing effect towards our model. So it will basically tend to be biased. Okay, whether it be under forecast or over forecast, it depends on our choosing of the smoothing parameter. Okay, right. So this is the advantages generally, because why I say generally, because we actually have 5 common type of exponential smoothing technique, which are single exponential smoothing, double exponential smoothing, Holtz method, adaptive response rate, and Holtz winter trend and seasonality. For each of these 5 common, I will show the demo in another video. Okay, so right, before we begin, okay, I will explain to you about single exponential smoothing. Okay, why we say that it is a single exponential smoothing? Because here we just need one smoothing parameter. Okay, smoothing, it is actually smoothing. Okay, smoothing constant. We will use alpha here to generate the fitted value and hence forecast the future value. Okay, so when we're talking about the smoothing constant, okay, this smoothing constant actually give the weightage of how our historical data the weightage of the how our historical data effects of the future value. Okay, so this is the explanation. But again, the difference between exponential smoothing and moving average is actually the weightage is different for each of the period, while if you use moving average, we have a fixed value of the fixed value of the fixed value of how the weightage, the fixed value of the weightage on how the historical data impacting the future value of the forecast value. Okay, right. So you can read more about this. Okay, again we're talking about the weight. The weight is actually what we say, the weight, the smoothing, okay, and how it affects the how the past observation affect the future value, okay, and also on. Okay, this is all about the alpha value, the smoothing constant that we choose before this. Okay, alright, so you can read. Okay, and then of course, to determine the best value of alpha, or to choose the best value of the smoothing constant, it is actually, there are actually two ways. Okay, whether you choose it subjectively or objectively. Okay, and again, alright, you can read details in your textbook. But for subjectively, okay, we say that when you choose the alpha, the constant, okay, whether it is, maybe you choose 0.2, okay, and then maybe you choose 0.8. It depends on how what are the most suitable smoothing constant. But of course, okay, there are two ways. You want to choose 0.2 or 0.8. Okay, whereby the first procedure is heavily relies on personal knowledge, so we say that it is subjectively. Okay, and okay, whether the alpha value is small alpha or larger alpha, okay, because we rely on our personal knowledge. Okay, small alpha is to be used for time series data that are relatively stable. Stable here means that less fluctuation. Okay, if dealing with a series that changes rapidly, large fluctuation, a larger alpha might be more suitable. Okay, because we want the weight, the smoothing constant, okay, to place greater importance on the more recent observation. Okay, this is why we choose a small or larger alpha. Alright, and another way to determine alpha value is what we call it as objective method. Okay, the objective method, we will determine the best value of alpha based on the certain measurement criterion. Okay, that, and the measurement criterion that we use is actually error measure such as mean square error and root RMSE, MAPE. Okay, all of this we call it as error measure. Okay, lesser better. So again, right, this is example on how we calculate MSE. Okay, and you can read how we choose, how we evaluate the best alpha value, okay, in your textbook under chapter 8. Alright, so we rely on the smallest error measure when we choose alpha based on the objective method, right? Okay, so for this discussion, I think that's all, right? So you can reply, you can comment if you need further explanation on certain topic, right? So I think that's all. Thank you for listening. Bye.